Hello, my name is Michael Dick and I'm a Principal Research Scientist at Green Imaging Technologies, and welcome to this webinar. This is the first in a series of 3 webinars where I will discuss work we've been doing over the last year in developing spatially resolved wettability measurement using NMR. In this first webinar, I will review how we employ NMR measurements to obtain the wettability index. It is known that NMR response varies as a function of wettability in the core samples. This information was used to develop an NMR wettability index based on T2 distributions like the one shown here. The NWI is capable of measuring changes in wettability as a function of oil-water saturations. This is unlike traditional methods, which are based on measurements at SWI and SRO only. In addition, the T2-based wettability method can be used to non-destructively monitor changes in wettability in real time, like during a flooding experiment or an aging procedure. Lowenstein and co-workers have been instrumental in developing the technique over the last decade. We furthered this work by coupling it to spatial T2 measurements to derive a wettability as a function of position in core samples, and that's what I'm going to talk about in this series of webinars. So the basic premise behind the method is that any T2 distribution for a sample of mixed oil and water saturation and unknown wettability can be predicted by mixing the 100% water saturated, 100% oil saturated, bulk water, and bulk oil T2 distributions. The mixing is done with saturation and wettability distributions and are applied via forward model to give a predicted T2 distribution at mixed wettability and unknown saturation. To obtain quantitative estimates of saturation and wettability, the model is placed in a least squares fit where the predicted T2 distribution is compared with a measured T2 distribution of mixed wettability and unknown saturation. With each iteration through the fit, the H and W functions are varied until the difference between the measured and predicted T2 distribution is minimized. Once the best fit is achieved, a final predicted T2 distribution at mixed wettability and saturation is obtained, along with the final saturation and wettability distributions. These final saturation and wettability distributions are then used to predict the wettability index and the water saturation of the unknown sample with unknown wettability and saturation. So I'm just going to spend the next couple slides talking a little bit more about the specifics of the forward model. The model says basically that there are 2 types of pores and 4 types of fluids in the walk. The 2 types of pores are either water wet or oil wet, and the 4 types of fluids are either oil in the center of the pores, oil on the pore walls, water in the center of the pores, or water on the pore walls. For the oil or water on the pore walls, the measured T2 distribution appear like the 100% water or 100% oil saturated distributions. For the oil or water in the center of the pores, the measured T2 distributions appear like either bulk water or bulk oil distributions. Then if we look at the equation for the forward model, we see that the W and H functions, the wettability or saturation functions, essentially are used to predict how much of each of these 4 types of fluids in the 2 different types of pores are used as contributions to the final predicted T2 distribution. So this slide shows typical saturation and wettability distribution functions. H and W are basically step-like functions which describe which pores are either filled with water or wetted by water based on their size. So for example, if we look at a typical pore size distribution like the one shown here, we see that when you couple it with the H function, only the pores shaded in light blue are filled with water. Conversely, for the wettability function and the same pore size distribution, we see that only the pores shaded in pink are wetted by water. The mathematical formulas for H and W are also shown. For our work, we chose H and W functions with only one variable each, either RA or RB. Varying RA or RB causes the distribution to move along the T2 axis encompassing more or less of the pores without changing the shape of the distribution. And now it becomes obvious how the H and W functions are used to mix the various distributions and predict a final distribution. For example, if we want more contribution from the T2 distribution shown here, we would move H and W to the right along the T2 axes, or if you wanted less contribution from the distribution, you would move H or W to the left. Once the final predicted T2 distribution has been calculated and the saturation and wettability distributions finalized, the wettability index and saturation can be estimated. The final saturation distribution is used to predict the saturation for the sample of mixed wettability and saturation via this formula here. The final wettability distribution is used to predict the wettability of the sample via this formula here. In our next webinar, I will show how we apply each of these equations to derive wettabilities and saturations for actual samples. So please join us in our next webinar, and if you have any questions, please feel free to contact us via email at info@greenimaging.com. Thank you.